Good morning, everyone. In the last class, we have discussed about the harmonic functions, how we are going to find the harmonic functions when u of x comma y is given or v of x comma y given by using the standard method. Or we introduced one method, that is Milne-Thomson method. It is also very useful for finding the analytic function f of z. Now, the last topic in the first unit, conformal mapping and bilinear transformation or Mobius transformation. Okay, the conformal mapping is related to the some properties, some definitions, some theory. That is the reason I am choosing this platform. Okay, otherwise we will go for the whiteboard and I guess solve the problems. Okay, now coming to the conformal mapping. Right, before going to the conformal mapping, see, yes, suppose if you take the function, y is equals to f of x. If I am going to take the function y is equals to f of x, y is equal to some x square, y is equal to some x cube. That means x is the independent variable, y is a dependent variable, y is depends upon x. For different values of x and y, yes, we tabulate the values and we locate the values of x comma y corresponding to, we locate the points on xy plane, and we can draw the graph. That graph represents, that is a relation between x-axis and y-axis under the mapping y is equals to f of x. It is simple way to represent the graph in the graph of the y is equals to f of x, or it is a relation between y-axis and x-axis. Right, here it is, suppose this is I am writing here, I will extend the notes also, no problem. If y is equals to f of x is a real valued function, then the equation y is equals to f of x gives the relation between the points on the x-axis and the points on y-axis. Right, if I am taking x is equals to 2, if you take the function y is equals to x square, x is equals to 2, y is equals to 4. 2 comma 4 point we are going to take. Right, 2 comma some 3 comma 9, 4 comma 16, and locate that point, you will get the parabola. Right, so easily represent the graph of y is equals to f of x on xy plane. But now we are in complex analysis. If you take the complex valued function w is equal to f of z or complex mapping, that means there is no such convenient here, because in order to map the complex valued function, first we need two planes. They are called z plane and w plane. Right, here it is, z is equal to x plus iy is a point in the region, some region in the z plane. Under the mapping w is equal to f of z, as x plus iy is associated to the u plus iv, where u is equal to u of x comma y, v is equal to v of x comma y. And I give an example for w is equal to z square also. Right, as the representation of z is equal to x plus iy in z plane and the corresponding w is equal to u plus iv in w plane, we can establish as graphical correspondence between these two planes, z plane and w plane. But it is easy to represent the points in x-axis and y-axis in one-dimensional. Now it is complex analysis, it is not possible. So in that case, we choose the two planes. They are complex two planes. They are z plane and w plane here. Is the correspondence the mapping, the correspondence defined by w is equal to f of z, or f of z is equal to u of x comma y plus iv of x comma y between the points in the z plane to the w plane. Such correspondence is called mapping or transformation from z plane to the w plane. Right, I don't know whether it is function or not. I don't want to tell the function. There is a relation, the points in the z plane to the points in the w plane. Yes, if you take w is equals to z square, if I am taking 1 comma 2, 1 plus 2i, it is associated to what? Minus 3 comma 4. Like that, 1 comma 2 is the input, output is minus 3 comma 4. Like that, there is a correspondence between the z plane to the w plane. That correspondence is called mapping or transformation. This is the mapping of the definition or transformation of the definition. Yes, transformation or mapping. Suppose I'm going to take see the figure, then we go for the. Suppose I'm going to take the z plane. This is z plane here. This is z w plane here. Yes, P is a point. This point is P. Yes, P is is a point with coordinates x0 comma y0. The corresponding under this mapping, under the w is equals to f of z, under the mapping, the corresponding point in the w plane is p dash with the points u0 comma v0, right? And the curve, the c1 is a curve in the curve in the z plane. The corresponding curve, that means the image of c1 is c1 dash here. The image of c2 is c2 dash here. C1 comma C2 are intersecting at a point P in the Z plane, and C1 dash and C2 dash are intersecting at a point P dash in the W plane, right? Suppose now I am going to concentrating on the angle between C1 and C2, and here it is angle between C1 dash and C2 dash. Here, if you want to find the angle between the two curves, you know that you should identify the point of intersection, then you draw the tangents to the curve. Right, since we here in the Z plane, if we concentrating on the Z plane, P is a point of intersection, right? Here P dash is a point of intersection with coordinates u0 comma v0 here. Here it is x0 comma y0. Okay, these are the tangents. The angle between the C1 and C2, the angle between these two tangents is same as the angle between the C1 and C2. The angle between C1 and C2 is same as the angle between C1 dash and C2 dash in the magnitude and same sense, same magnitude and same sense. Such transformations or such mapping is called conformal mapping. Now coming to the definition, whatever we are discussing, right? This is a formal definition of the conformal mapping. Suppose under the transformation w is equal to f of z, u of x comma y, if w is equal to f of z means w is equal to f of z is equal to u of x comma y plus iv of x comma y. This is the imaginary part and this is a real part. The point p x0 comma y0 of the z plane is mapped to the point p dash u0 comma v0 in the w plane. Suppose c1 comma c2 are any two curves intersecting at the point p x0 comma y0. Suppose the mapping takes c1 and c2 into the curves c1 dash comma c2 dash. So c1 curve is associated to c1 dash curve, c2 dash is associated to c2 dash curve, which are intersecting at a point p dash u0 comma v0 in the w plane. If the transformation is such that the angle between C1 and C2 at x0 comma y0 is equals to both magnitude and sense to the angle between C1 dash and C2 dash. When the both magnitude and sense, the angle between C1 and C2 is same as the angle between C1 dash and C2 dash. Such transformation is called, such mapping is called conformal mapping or conformal transformation. Is it clear? If you see this figure, you can get the clarity. Right. Suppose only if the transformation preserves the magnitude but not sense. Right. Sense means anti-direction clockwise. Generally, the measurement of the angle we can take in the anti-clockwise sense. Right. Only if we concentrating on the magnitude, but we don't. If we neglect the sense, right? In that case, we say that the transformation is called isogonal transformation. This is a formal definition, right? Now, if you think this definition, if you see these two figures, is it not possible? Suppose W plane, there is a region, big region, right? In the Z plane also corresponding region we have. So region is nothing but set of infinitely many points are there. It is not possible to draw the C1s and C2 at a time, right? So many curves, infinitely many curves are existing as in the domain region as well as in the codomain region also. So in order to overcome this situation, this is a formal definition, it is clear. In order to overcome this situation, associate conformal mapping with our analytic function. This we can understand easily by using this theorem as conformal mapping theorem or conformal transformation theorem, but proof is not needed. Only we understand the statement. Okay. If f of z is analytic of z in the region R, there is a region R which is in the z plane. The function f of z is analytic in the region R. Okay. To the z plane, f of z is analytic of z in the region R to z plane, and f dash of z is not equals to 0. Whatever z you are taking in z plane, f dash of z is not equals to 0 in the region R, then the mapping w is equal to f of z is conformal at all the points of the region R. See how the conformal mapping is simple, right? See, only where you are going to concentrating on whether the given transformation is conformal or mapping, whether given mapping is conformal or not, just you see the f of z. If you see the f of z, if f of z is analytic Clear? And f dash of z not equals to 0 for every z. Directly you can say it is a conformal mapping or it is a conformal transformation. Suppose if you take f of z is equals to, or w is equals to f of z is equals to z square, you know that if you take z square, in this case what happened, it is clearly we given the example here, it is f dash of z is equals to what, z square, it is 2z. F dash of z is equals to 2z, is 2z where it is 0, where it is 0 at z is equals to 0. Sorry, I am unable to writing here. At z is equal to 0, z is equal to 0, at z is equal to 0, f dash of z is equal to 0, except 0 it is conformal, right? Okay, this is, if f dash of z is equal to 0 at a point, then that point is called critical point of the function. You know that this is a basic definition. If you take the function of one variable f of x, right, the stationary points, the critical points are given by f dash of x is equals to 0. If you take f of x is equals to some x cube, 3x square is equal to 0, x is equal to 0 is the critical point. When we have the critical point as stationary point, we go for the first derivative test or second derivative test to that is to determine the maximum minima, PUC 1 I think, right? Next, if you go for the engineering one, in the previous semester, or I think first semester of E1, right, how we are going to find the maximum minima of the function of 2 variables and 3 variables, right, by using the partial derivatives, dou f by dou x, dou f by dou y, dou f by dou z, right, and here dou f by dou x is equal to 0, dou f by dou y is equal to 0, so all these two equations you will get a point x comma y, that is a critical point. The derivative of the function is equal to 0 at one point, that point is called critical point or stationary point. Same definition here, right? Is it clear? We can understand easily by using this conformal transformation theorem or conformal mapping theorem, right? Okay, if the function is analytic and f dash of z is not equal to 0, we say that it is a conformal mapping or conformal transformation. Okay, now we are going to discuss about the standard transformations here. One by one I am going to discuss, you should concentrating on this, right? Standard transformation. Suppose I am going to take w is equals to z plus alpha. W is equal to z plus alpha, where alpha is any complex number and which is complex constant. Suppose I am going to take z is equals to x plus iy, w is equals to u plus iv, and alpha is equals to alpha 1 plus I alpha 2. Okay, here w is equal to z plus alpha, so which that implies u plus w is equal to u plus iv, that is u of x comma y plus iv of x comma y plus e equals to x plus iy plus alpha 1 plus I alpha 2, and separating the real parts and imaginary parts are x1 plus alpha 1 plus I into y plus alpha 2. So comparing real and real parts, here it is real part is LHS u, here it is x1 plus alpha 1, here imaginary part is b, here it is y plus alpha 2. So that what we have, u is equal to x plus alpha 1, b is equal to y plus alpha 2. It represents each x comma y in z plane is transformed to the x plus alpha 1 and y plus alpha 2. X is transformed to the x plus alpha 1, y is transformed to the y plus alpha 1, or the ordered pair x comma y associated to the x plus alpha 1 comma y plus alpha 2. You know, this is nothing but translation. Why it is called translation? You know the translation of axis. Yes, if the origin is shifted to one point to another point, then the old coordinates x comma y is associated to x1 plus h, y1 plus k. Same way, the position is different, but the curve is same, right? Whatever the curve from z, if you draw in the z plane, same curve you are going to expect in the w plane. Is it clear? Suppose if I am taking the straight line in the z plane with height of 1 unit from the real axis, right? If I am taking alpha is equals to 1 comma 1, that is 1 plus 1 I. Yes, what you are going to expect, here it is the height is 1, again the height is in the w plane 1 comma 1, again 1. So yes, the straight line in the z plane with the height of 1 unit with respect to the real axis, the corresponding image is straight line, but here it is the height is 1 plus 1, 2 units from the real axis in the w plane, right? That's why straight lines are associated to straight line, and circles are transformed to circle, parabolas are transformed to the parabolas. Whatever the curve you are drawing in the z plane, same curve you are going to expect in the w plane. The position is different, right? This is the one of the standard transformation, that is translation. Okay. Okay, here this under this transformation, the image of Z plane is simply translation of that image of the W plane. So that by this translation, the straight line is mapped to the straight line, so and circles are mapped to the circles. Whatever the curve you are taking in the Z plane is mapped to the same curve in the W plane. The position is different. This is the translation. Okay. Next, this is very important conformal mapping, especially for the ECE people. Yes, in this case, what here we have, whatever the curve, whatever the curve or straight line circle you're considering the Z plane, you're expecting same. Yes, if you go for the other transformations, standard transformations, not like that, right? As a communication engineer, you should concentrating on this one, right? If you go for other concepts of the conformal mapping, you will get a clarity. Okay. Now coming to the second standard transformation is rotation and magnification. Right. Rotation and magnification, W is equals to alpha Z. If I am taking the transformation is what? W is equals to alpha Z, where alpha is a complex constant. I am writing W Z alpha in terms of polar amplitude form or magnitude, absolute what is that? Polar magnitude form. Okay. Z polar coordinates, Z is equals to R e to the power of I theta. It is a complex number. It is in the form of Z plus X plus I y, like that, no? So W is equals to capital R e to the power of I pi. And alpha is a complex number, which is a constant complex number, become beta and gamma are the constant, beta e to the power of I gamma. So now the given transformation is what? W is equals to alpha Z. So W is equals to R, what I have taken, R e to the power of I pi. R e to the power of I pi is equals to beta e to the power of I gamma into uh, R e to small r e to the power of I theta. Right? This can be written as this can be written as R e to the power of I pi is equals to beta R. Here it is beta R e to the power of I into R plus theta. On comparing on both sides, here it is the coefficient of e to the power of I pi is what? Here R LHS, here it is beta R. Yes, the coefficient of I, the power e power I is pi, here it is R plus theta. So R is equals to beta R, pi is equals to theta plus gamma. Thus under this transformation, the point R comma theta, in polar coordinates, the point R comma theta in Z plane into the point P dash beta R comma theta plus gamma in the W plane, right? This is the rotation and magnification transformation. That means here it is, the input is R comma theta, the output is completely different under this transformation, that is beta R comma theta plus R. In other words, the transformation magnifies the radius vector of P by beta is equals to norm alpha, mod alpha, and its rotation through the angle gamma is equals to amplitude of alpha, right? Now coming to the third standard transformation, inversion. Right, here it is inversion. Yeah, it is inversion. Inversion is W is equals to 1 by Z. Z is equals to R e to the power of I theta, that is standard. If I am taking here in the Cartesian coordinates, I am taking Z, the complex number as X plus Iy. In polar coordinates, I am taking complex number, the standard complex number, the standard formula for complex, taking the complex number R e to the power of I theta. So Z is equals to R e to the power of I theta, 1 by Z. W is equals to R e to the power of I pi. Therefore, the transformation is W is equals to 1 by Z. Yes, R e to the power of I theta is equals to 1 by R e to the power of I theta. So that implies R e to the power of I theta is equals to 1 by R e to the power of minus I theta. Just comparing on both sides, capital R is equals to 1 by R, pi is equals to minus theta. That means the point R comma theta in the Z plane is mapped to the point 1 by R comma minus theta in the W plane. This is the inversion transformation. Okay. Now we are going to discuss some special type of conformal transformations here. Also very important. Okay, first one, the standard transformation, you know that as I am taking as the transformation W is equals to Z square. Yes, that is f of Z is equals to Z square. W is equals to Z square. Is it analytic? Yeah, it is analytic everywhere except to 0. Okay, here it is, sorry, w is equals z square. So here it is w by dw by dz is equals to 2z. Sorry, it is analytic everywhere, but I want to check whether it is conformal transformation or not. In that sense, I am writing here the derivative of z square is 2z. That means value of z, the derivative becomes 0 at z is equal to 0. That means it is conformal. It is everywhere conformal except 0. So the transformation is conformal except 0. Right. So w is equal to z square. Then w is equal to what? U plus iv. U plus iv is equals to x plus iy whole square by expanding by using the formula a plus b whole square. X square minus y square plus 2ixy. So u is equals to x square minus y square real part and imaginary part v is equals to 2xy. Now I am going to concentrating on how it is transforming, right? Okay. The transformed equations are, if I am taking x comma y in the z plane, that x comma y is transformed to what? X square minus y square comma x square minus y square comma 2xy, right? If I am going to take one case, I am going to consider here, if x is equals to a, x is equals to a means vertical line, okay, or the same, the image of x is equals to a is x is equals to minus a. If the region existing in between, see the figure, if the region existing in between x is equals to minus a and x is equals to a in the z plane, the what I am going to expect the corresponding image under this mapping, right? That is very important. That is we are going to discuss here. Okay, here under the mapping w is equals to z square, if I am going to take for a special case, if I am going to take x is equals to a, yes, if I am taking x is equals to a, the image is what? X is equals to minus a. That means there is a, we are taking one region in the z plane that is between x is equals to minus a and x is equals to a, right? Here it is, if I am taking x is equals to a, u is equals to what? A square minus y square. V is equals to 2ay. X is equals to a, fixed yes. If I am fixing the x is equals to a, right? U is equals to a square minus y square, v is equals to 2ay. You can eliminate y in these two equations. From these two equations, you can eliminate y. And here it is, v squaring on both sides, v square is equals to a square y square. Right? And substitute this y square is equals to what? A square minus u. A square minus u. Substitute in this equation, you will get equation v square is equals to 4a square into a square minus u. So it represents a parabola. Following, that is a parabola. The image of this strip, that means this is the vertical strip, right? Between x is equals to minus a and x is equals to a. The image of vertical strip is a parabola. Input is different, output also different. Input is vertical strip, the output we can't expect it is a vertical strip or horizontal strip. That is the reason, right? Okay. If you want to take the photos by using I think satellite photos or other things, we are using some small device in the input, but the radius of the image is completely different, right? Yes, by using this concept only, they are using that one. Okay. So if I am going to take y is equals to b, y is equals to b, obviously it is a vertical line. So here, sorry, here it is not y is equals to minus a, here y is equals to b. Here it is y is equals to b constant. So if I am taking y is equals to b here, what is the image here? Y is equals to minus a. That is horizontal strip. If I am going to take the horizontal strip in the z plane, right, then u is equals to, under the transformation, u is equal to x square minus y square. So x square minus b square, v is equals to 2xb, and eliminate x square in these two equations in the same procedure, the previous procedure. You will get v square is equals to 4b square into b square plus u. This is a parabola in this transformation. Clear? This is a parabola. Suppose if I am considering both x is equals to a and y is equals to b. X is equals to a and y is equals to b. So how, if I am taking x is equals to a here, what is the image? X is equals to minus a. I am not writing, not drawing here. X is equals to minus a. Y is equals to b, here y is equals to b. So the region is transformed to the region between these two parabolas. If I am taking x is equals to a, what is the parabola we have in the from the first case? V square is equals to 4a square into a square plus 4. If I am taking y is equals to b, what is the parabola in the second case? V square is equals to 4b square into a square plus 4. Right? The reason is, the region bounded by x is equals to a and y is equals to b is mapped to the
The parabola is bounded by s v square is equal to 4a square plus u, or v square is equal to 4b square a square minus u. Next, the standard transformation I am going to take, the transformation of w is equal to e to the power of z. W is equal to e to the power of z. In this case, listen, it is exponential. Z is equal to x plus I y I am taking. That is, z is in the Cartesian, w in the, it is in the polar. W is equal to r e to the power of I theta I pi. W is equal to r e to the power of I pi. Z is equal to x plus I y. The transformation is, w is equal to e to the power of z. That implies r e to the power of I pi is equals to e to the power of z. So it is e to the power of x plus I y. That implies r e to the power of I pi is equals to e to the power of x into e to the power of I y. On comparison, capital R is equals to e to the power of x and pi is equals to y. See, what is r, what is pi in the w plane? Right, r is the distance from origin to the point. Pi is the angle. If I am taking OP, like this, OP, if I am taking angle made by the OP in the W plane. Right, now I am going to discuss some special cases. But, and also, as W is equal to e to the power of z, the derivative of e to the power of z is e to the power of z. Whatever z we are taking, e to the power of z is not 0. So, it is conformal everywhere. Right, there is no critical points are existing for e to the power of z. Okay. Now, some special cases we are discussing here. Y is equals to alpha. If I am going to take y is equals to alpha, y is equals to y1, it is nothing but it is horizontal line. Yes. Then y is equals to alpha, pi is equals to what? Alpha. Y is equals to alpha, pi is equals to alpha. So, and y is equals to beta. One more case. Y is equals to alpha, y is equals to beta, but alpha less than or equals to y is less than or equals to beta. The y lies between alpha and beta. So if I am taking y is equals to alpha, pi is equals to y, no? Pi is equals to alpha, pi is equals to alpha. Y is equals to beta, pi is equals to beta. So the horizontal strip between y is equals to alpha and y is equals to beta is mapped to what? It is nothing but wedge. The triple integrals we discussed, no? It is a wedge, right, between pi is equals to alpha and pi is equals to beta. Pi is equals to alpha is straight line. Pi is equals to beta also line, right? Here the input is different. The input image is different. The output image is different under the mapping as w is equals to e to the power of z. Is it clear? The here it is horizontal strip. Here it is between the pi is equals to alpha and pi is equals to beta, right? If I am going to take alpha is equals to 0, beta is equals to pi. Alpha is equals to 0, what happened? Alpha is equals to 0, then pi is equals to 0. Pi is equals to 0 means horizontal line in the W plane. Okay. Yes, if I am taking beta is equals to pi, then pi is equals to pi. Here it is. Listen, this is a example for that. Listen, particularly the region in the Z plane between y is equal to 0 and y is equals to pi. This is a horizontal strip. Here it is a horizontal strip here. Y is equals to 0 and y is equals to pi. Right. This represents pi is equals to 0. Here it is pi is equals to pi. What is the image of y is equals to 0 to y is equals to pi? Here it is the entire W plane, half of the entire W plane. This is the image. Is it clear? This is the image. Pi is equals to 0 to pi is equals to pi. Right. Next one. When I am taking x is equals to 0 here. When I am taking x is equals to 0. X is equals to 0, what happened? Capital R is equals to, under this transformation, what we written? R is equals to e to the power of 0, that is 1. Right? R is equals to 1, W is equals to what? 1 into e to the power of I pi. The radius is 1. The radius is 1. Right? The complete I am taking, complete space I am taking. So radius 1 means there is a unit circle. X is equals to 1, capital R is equals to 1. So it is modulus of W is equals to 1. Modulus of W is equals to 1 represents unit disk. The image of the x-axis, the image of the x is equal to 0 means y-axis. The image of the y-axis is a unit circle. under the mapping, under the conformal transformation,
W is equals to e to the power of z.
Next, if I am going to take y is equals to 0, so pi is equals 0. Y is equals to pi, so pi is equals to pi, and x is equals to 0. Both are here.
First case, second case, third case I am considering here. Y is equal to 0, x-axis. Y is equals to pi, that is above the x-axis, and x is equals to 0 means y-axis. The region bounded by
Y is equals to 0, y is equals to pi, x is equals to 0 in the z plane. This is the reason. Y is equals to 0, y is equals to pi, x is equals to 0. If I am not writing x is equals to 0, you will consider this part also. Okay, y is equals to 0, y is equals to pi. Yes, the image of this is what? Here, this is the half circle. Half circle, is it clear? Why it is half circle? If I am going to take, if I am not taking what? Y is equals to, in the previous full circle, how we can get the full circle?
only x is equal to 0 I am taking.
Is equals to 0, y is equals to pi. That's why this is the image. Next, last case. Here, y is equals to mx.
Y is equals to mx. R is equals to what we have? E to the power of x is e to the power of
Capital R is equals to e to the power of x, right? So, y is equals to mx, x is equals to m, or e to the power of 1 by m into pi. Yes, so that the line y is equals to mx. Y is equals to mx means the straight line passing through origin. The image of the line in the z plane is, so that the line y is equals to mx in the z plane corresponds to the
equiangular spiral.
Sorry, spiral. Right? Y is equals to mx in the z plane corresponding to the equiangular spiral in the w plane. Right? Different images. Not only this, I am considering only 4 or 5 cases for the e to the power of z. If you are taking the different conditions, if you are putting the different conditions in the z plane, right, you will get the different images, right? This is the importance of the conformal mapping. Class, we are going to solve the problems on the conformal mapping, right? Then how to find the image when transformation is given. Yes, you do one thing. Yes, what I have taken two transformation standard, some transformations. In this case, w is equal to z square I taken, and w is equal to e to the power of z.
You may take w is equal to sin z, w is equals to cos z, and w is equals to log z, right? Based on that,
you are going to solve it. You are going to check the transformations. Okay. Thank you.